Hello, good morning, good afternoon, whenever you're watching this. So, there was a change in plans in the night. It's almost 2 a.m., 1:52, and my son Ian just got sick for the second time and has a fever and is not doing so awesome. My husband can't take off for a couple reasons. So, anyway, the reason why I'm telling you this is because this video is important enough that I am waking myself up out of a sleepy state in order to make it. So please make it a priority to watch it and to do these notes too. I know that you're awesome and you probably just would anyway, but just saying, these are all really big ideas and I want to make sure that you know them. I'm putting it on a video so you can watch it as a class together to take notes, but then afterwards you can also rewatch it if there's any parts that you didn't understand, or you can ask me about, hey, I didn't understand this part. Can you help me with it? Okay, so what I want you to do is right now, everyone open to page 174 in your daily lessons. You're going to be doing 174 through 176. So open it up to there. And the very first thing is going to talk about average value of a function. Okay, so pause this while everyone's getting it, and then unpause when everyone's good. I'm just going to keep going. Okay, the first one, if we talk about how we found average velocity, think about velocity is already a rate. It's a slope of position. So if we're talking about average velocity, which you already have this in the first blank, I'm just writing it bigger because it's hard to see mine. Average velocity, you would do position at B minus position at A over B minus A. You're finding the slope of the secant line of position. Then the next question on here says, how do we find average acceleration? Acceleration is a rate also. It is the slope of velocity. So I'm going to say average acceleration and then I would do the velocity at B minus the velocity at A over B minus A. If you're not convinced on this, try this with some units. So if you're like, oh, this is all running together in my head and I don't like this so much, it's okay if you don't like it, you're still gonna do it anyway. But position, think about the units. This would be like meters. B minus A is some time. Hey, meters per second, does that make sense for velocity? Yes, it does. This one, velocity, would be meters per second over seconds, which makes sense for average acceleration. Okay, so these are all things that you know so far. So keep moving on. And then there's this question down here. It says, what is 1 over B minus A? And you can see on yours, because obviously this little, of this integral from A to B of A of t dt. What I want you to do, and I can actually do this because I'm not on a smart board, is forget about this 1 over B minus A for a second and just concentrate on this integral from of A of t. Oh, sorry, it's really late. dt from A to B. I was saying B in my head and it wrote B. Anyway, this integral of A of t dt from A to B, and forget about that B minus A for a second. We did this a little bit in class because you've had some pre-responses, and I think number 58 in the homework, you had to do something too. But if you do this and just think about what that means, the integral from A to B of A of t actually means the antiderivative of A of t, which would be B of B minus B of A, according to the fundamental theorem of calculus. What that means, I'm going to move this over a little bit. What that means is the change in velocity from time A to time B. So here's what I'm going to do. If I put this in front, I put 1 over B minus A. 1 times B minus A, 1 over B minus A times this integral is the same thing as V of B minus V of A over B minus A. So what we have now changes up entirely because this was the change in velocity. But as soon as I do this, this is that same thing we were talking about up here, which we just said was average acceleration. So if you ever see something that has a 1 over B minus A in the front, or you're asked to find the average value of a function. This is my function a of t. I'm integrating it, which takes it back to v of b minus v of a. This is 1 over b minus a. This is going right here. So I'm back to average acceleration. I'm back to the average value of this function within the integral. Okay, let's try it with another one to make sure it works. The v of t. So we went from a to b of v of t. Also, I'm really sorry. I can tell that I'm tired because it took me a second to say that before. I've got the integral of v of t from a to b. The antiderivative of velocity, so fundamental theorem of calculus, would be the change in position. If I have the change in position, that's all well and good, fundamental theorem of calculus, that's really important. But if as soon as I multiply by 1 over b minus a, it's the same as dividing this by b minus a, which we said up here is the same thing as average velocity. So you can see here, integrating velocity, it takes it back to position, but this 1 over b minus a then brings it back to average velocity. The thing is, you can do this with any function. You can do it, and we'll see a bunch of them. Anytime you want the average value of this function, so of velocity, of acceleration, of position, you can do this. It's just harder to visualize what that means. If I wanted the average value of position, I could do this. This is the average value of the position function. This one's harder to do because we don't talk about what is the antiderivative of position because it just doesn't make sense for what we use it for usually. Okay, so if I keep going on, if I want the average value of any function, I think this is kind of hard to see again, but I'm going to keep going. This would be 1 over b minus a of the integral from a to b of that function f of x. So average value of any function, 1 over b minus a, the integral from a to b of that function. This is different than when we talk about the average rate. If we're talking about the average rate of a function, that would still be the slope of the secant line. So f of b minus f of a over b minus a, that's the average rate. If we want the average value, this is how we're doing this. It's hard when the average value happens to be right. Okay, so here's what I want you to do. So if you're talking about the average value of this functions, I know this is going to be kind of hard to see because I have it in pencil, but it kind of works out better in the end too. This is a calculator problem, and the second one is non-calculator, just so you can make sure that you can do this by hand. The first one, you can't do by hand because it's already a product, but we don't have some reverse product rule or anything that we've been doing. What I do is I'm going to integrate this. I'm going to integrate the f of x from 1 to 3. So you can put this on your graphing calculator. You can do Math 9. You can go into your graph and graph this in y1, the f of x in y1. But find the area under the curve if you were graphing in y1, or just do Math 9 and then put in this exact function. And you should get 11.696354. That would just be the integral from 1 to 3. If you want the average value of the function, you need to make sure you do 1 over b minus a, which in this case would be 1 over 3 minus 1. And you should get 5.848. But pause at any time. I know I gave that one away a little bit. Pause the video now so you can try the average value of the function on the next one. Okay, I'm still going to keep talking because this is a video and I can do that. If I want the average value of this function on this interval, so I've got average value of the function, so I'm going to do 2 to 6. My function was 2 minus 4x, so I'm going to I'm going to write that in here. But this isn't enough. Right now, if I do this, what I'd be finding is the antiderivative, which I can. The antiderivative of this would be 2x minus 2x squared. And then I evaluate that from 2 to 6, thinking, what is f of 6 minus f of 2? All of that's well and good, but I didn't find the average of the value of the function. What I need to do is 1 over 6 minus 2. So take my answer, and whatever I get here, multiply by 1/4. Take a minute to do that, pause that, and now I'm going to tell you the answer. The answer to this one, you should get -14. Okay, moving on. We want to get the whole way through 176 today. So this was 174. Make sure all the people around you are good. Like, hey, Miss DeWald's not here to check in on you, so I'm checking in on you because I care about you and I think you're awesome. You can tell them that too. It's a good way to have somebody's Friday go. Okay, these type of problems I like so much. And it's a good thing I like them just because they appear over and over again. I was talking to a few of you about this type of problem yesterday. Okay, so a ski resort uses a snow machine to control the snow level on a ski slope. Over a 24-hour period, the volume of snow added to the slope per hour, and then it gives this. So we've got a rate. S of t is the rate that snow is added. And if you're thinking about that, this could be, if we're talking about the rate that's added, it could be actually snowing, but most likely if it's a ski slope, oh wait, and it says that there's a snow machine. So there's a snow machine, so this is at a steady rate, or at least a rate that can be written as a function. The rate at which snow melts is modeled by a different equation. So the m of t is a rate at which snow melts. Both of these are derivatives right now, even though they're not written as s prime or m prime. Like, this is the rate snow is added, so s of t, m of t is the rate at which it melts. Okay, and we also see at time t equals 0, the slope holds 50 cubic yards of snow, and it tells you about the units, cubic yards per hour, for both of these rates. If I want the total volume of snow added, be really careful about this, but it's only over the first 6-hour period. I'm going to find my integral from 0 to 6, because for 6 hours, and the rate snow is added was just the s of t. This is going to tell me my amount of change in the snow added from 0 to 6. So this is all I want to do for that. You can put this in your calculator. You're not going to ever have to do 24 minus t sine squared of t over 14. That would be crazy. Well, sine of 2 over 14 all squared. You're not going to have to do that on your own. So you put this in your calculator, you should get 142.413. Then you have to think about this and think, okay, what units should go on this? Again, pause at any time. I'm spoiling this by giving you the answers first. I'm sorry, it's like I'm opening up your gifts at Christmas, but make sure that you're pausing this and saying, yes, I know how to get that, or no, I definitely do not. In part B, this one says find the value, and it says 0 to 6 of m of t dt and 1 over 6 of the integral from 0 to 6 of m of t dt. Sorry, I'm saying things weird. I'm super tired. Using correct units of measure, explain what each means. Okay, so the first two things, when you're finding that value, this is part B. Yeah, you can still see that. This integral from 0 to 6 m of t dt, it's just a number on your calculator. So if you do that now, you should get 81.823 cubic yards. Or wait, sorry, I shouldn't have said cubic yards. 81.823. Again, you can pause this, make sure you can get that. If I do the same thing, but I multiply that number by 1/6. Be careful about this. If you had this question on a test, you would have to make sure that you have many places after the decimal, then multiply by 1/6, so that you can have the degree of accuracy to the thousandths place, meaning 3 places after the decimal. Okay, so your calculator is going to tell you this much. You need to figure out what is the meaning of this in this problem. So using correct units of measure, explain what each represents. In the first one, if this was the rate that snow melts, and it says that it's melting in cubic yards per hour, If I integrate cubic yards per hour dt, something with that, when I take the antiderivative, like I'm doing right here, I'm just going to get back to cubic yards. Same deal down here, but this 6 from 0 to 6 means hours. So this one really is cubic yards per hour. Instead of writing all this down, I'm going to read this too, but you would have to say this integral from 0 to 6 of m of t dt, this means that in the first 6 hours, so from 0 to 6 hours, 81.823 cubic yards of snow has melted. Yeah, because M was talking about the melting rate. So this is not, I said the number of cubic yards of snow that have been added. Think about this as the change in cubic yards, but because this is M of t, we're talking about melting. So I can say 81.823 cubic yards of snow in the first 6 hours, because I have to do this integral from 0 to 6, has melted. If I say that 1/6 of that integral, that same integral, this means that snow is melting at an average rate of, because remember that's the average value of the function, so it's the average rate that snow is melting. And that's at 13.637 cubic yards per hour. And again, this is over the first 6 hours. Okay, in the next one, part C, it just says, is the volume of snow increasing or decreasing at time 4? We've done a bunch of problems where we want to know, is a function increasing or decreasing? And what we do is we look at the derivative. If I'm talking about the volume of snow on this mountain, so this is C, the volume of snow, I don't know what that is. Well, I can figure it out, but we're not going to do that yet. If I want the derivative, I need to talk about the rate snow is added minus the rate it is melting. This is my derivative. It's already there. And so if I want to know, is snow increasing or decreasing, you can do it a couple ways. You can substitute in 4 into this whole thing, and you can see, is this number positive or negative? If V prime is positive at 4, that means the volume of snow is increasing. If V prime is negative at 4, that means the volume of snow is decreasing at 4. The other thing that you can do is just take S of t, or S of 4, and M of 4, and find those two answers, and I found 23.682 yards cubed per hour, or so cubic yards per hour, and M of 4 was 11.881. Again, you can stop this video and confirm that, but that's cubic yards per hour. I can see that the rate that snow is being added is greater than the rate that the snow is melting, so I know the volume is increasing. But again, you could just put in 4 here and see, is this number positive or negative? In part D, this is where I would actually be wanting to find this part. Well, kind of. I would want to know the volume after 5 hours. Okay, so part D, we're talking about the volume after 5 hours. Well, first of all, I need to know how much snow was there to begin with. And at the very beginning in this problem, it said that there were 50 cubic meters of snow when time equaled 0. The next thing that you would do is figure out, well, how much snow has been added in that time. So I'm going to do the integral from 0 to 5, because it's over the first 5 hours. Snow was being added at a rate of S of t. So now I've got 50, plus this is how much snow was added, because this was the amount of change, 0 to 5, of snow being added to the mountain, minus 0 to 5 of how much is melting. This same idea comes up over and over again in all sorts of things. It could be, these are real things that have happened on the AP exam before. Penguins, grass clippings, bananas. If you're talking about the rate bananas are being added to a shelf and then taken away from a shelf, like people are buying them, you could do this. How many bananas were there to begin with? How many bananas are there at a given time? Penguins, how many penguins were on an island, and then what rate were they being born and what rate were they dying. Very sad. But I think it actually, the penguin population was increasing, so not too sad, unless you don't like penguins, then that's sad. But then, you know, yeah, whatever. Maybe I shouldn't talk about penguins as much in the middle of the night. And you might think that's strange, but you also know me, and this is what I do in class too, so I guess it's not that strange. Last one on here, so you should be able to find this. By the way, your answer should be 95.335 cubic yards of snow, so make sure that you can get that. But in D, it says, suppose the snow machine is turned off at time t equals 10. Write, but do not solve an equation that can be solved to find time t equals k when the snow would all be melted. Don't be freaked out by that. If you're thinking about the snow being all melted, this problem is actually way easier than the other ones because you don't have to do anything with it. You know how this one, it all equaled 95.335? In the next one, I want the volume to be 0 because I want the snow to all be melted in this problem. So I'm going to say 0 equals. Then I have to do 50 because that's how much snow was there, plus the snow was there to begin with, the initial value, plus from 0 to time 10, snow is being added. But then it's not going to just stop melting at time 10. I'm going to go 0 to the time k when the snow is all melted. This is my equation. You could actually do some other things on this too. There are multiple answers that are allowed. If you would have found this value first, you could have gone and used your answer from up here and then gone from 5 to 10 or 5 to k. And there's some other possibilities. But I would say the snow is all melted, so we've got 0. You're still doing the initial condition, plus the amount that was added from 0 to 10, the amount that was melting from 0 to k when it was all done melting. That's the only time it stops, when there's no more to melt. Okay, this video is getting kind of long, but that's okay. We're gonna keep on moving on because we're on our last page. What? Already? I know. Can you even believe it? It's Friday and we're almost done with this, which is a little sad, but don't worry. You get to practice this at home. Hooray. Okay, 2003. I'm waking up a little bit. 2003 AB number 6 part B. So this one is nice because it's already part of a free response problem. Also in the year I graduated, makes me feel kind of old, but not too old because, you know, whatevs. But in 2003, this question was asked. It said, let f be a function defined by this. And so I've got f of x and I've got a piecewise function. So one function from 0 to 3, one from 3 to 5. It's asking me to find the average value of f of x on this closed interval from 0 to 5. And so what I want to do, if I'm thinking about average value, we just said to find the average value of a function, I can do 1 over b minus a times this integral of f of x dx. And I really want to go from 0 the whole way to 5. So this is all well and good, and by the way, this would be 1 over 5 minus 0 for this particular problem. And that's how I can find the average value of a function. But the problem is, I've got a piecewise function. So you need to remember what were those rules of integrals that we used before. Okay, so I'm still going to say 1 over 5 minus 0 is just 1/5. And whatever I get, I'm going to break this up. This integral of f of x, I can break it up into 2. Because remember, this is also the same thing as doing the area under the curve from 0 to 5. So there's no reason I can't break it up from 0 to 3. And then 3 to 5. So what I want you to do is try to figure out, could you solve this now? Could you do 1/5? And then from 0 to 3, you'd be looking at this part. From 3 to 5, you would get this part. You should stop this video and then try to do this. Okay, great, you're back. It's probably funny because most likely you didn't stop the video and you just heard that, but that's okay. I'm gonna say 1/5. To solve an integral by hand without a calculator, you're gonna do the antiderivative. So this would be x plus 1. Right now it's x plus 1 to the 1/2 power. I'm gonna make this 3/2. Divide by 3/2 is the same as multiplying by 2/3. And you wanna evaluate this from 0 to 3. This one I'm going to do the same. The antiderivative of 5 would be 5x minus, add 1 to the exponent, divide by my new exponent. So I'm going to take 1/5. Here I'm going to do f of 3 minus f of 0. Whatever I get, I'm going to do the same thing over here. F of 5 minus f of 3. And after all this work, there's so many fractions. What you should get is 4/3. That's after you multiply it by 1/5. So for this business here, what do you get? You get 2/3 times 8 minus 1. I substituted in and then multiplied by 2/3. It doesn't matter when you do this. But for all of this mess, you should get 20/3. I can multiply that by 1/5. 20 divided by 5 is 4. I hope you can see all that, but yeah. Okay, so you should look at your homework packet and see what you have to do. Actually, I can tell you this because then people don't say, oh, I didn't know what I had to do. Is homework still due? Homework's definitely still due. There are only 2 free responses that you don't have to do. Oh, sorry. Do this. Should you guys see this? Avocado. It's good times. Okay. So I'll put this a little bit closer so you can see it. So this is today. That's 2/7. Well, yeah, it's today already. It's 2. You're going from 174 to 176. We did that. Great. You're going to finish the regular numbers, like the regular problems in your homework, which are 65 to 71. You're also going to do 2003 AB number 3, which is not the one we just did. This one, because it's in this side, should be right behind 71. There are 2 problems in your homework that you have not done yet, the free responses, 2004 and 2001. These are the only 2 that you don't have to have completed by Monday. On Monday, your homework packet is due. I'm pausing so you can be a little bit sad. Okay, but now you can be happy because look how much calculus you're going to get to do and learn over the weekend if you haven't done it already. And if you've done it already, air 5. Woo! This is like a true asymptotic high 5 because I really can't ever reach you. But that's what's coming up. Okay, thanks so much for being awesome. Thank you for caring. I appreciate it. And I appreciate you. And I'm actually just super sad I'm not there on a Friday. But it's all cool because, you know, stuff happens and other things are important in life too. Okay, have a great day and I will talk to you later. Please send me any remind messages if you have any questions or an email. Okay, bye.